everyone, welcome to today's video on comparing proportional relationships in table and equation form. So we know that two quantities are in a proportional relationship, or we say they are proportional, if all of the ratios that relate the quantities are equivalent. So you can see this in our table here. So we'll have cups of rice. I'm just going to say that's X for the moment, but that is the thing they're talking about. And then the number of people is Y. So this is a real world problem talking about how many cups of rice we have and how many people we can feed with that rice. Okay, but here, if we take the ratio of y to x, the number of people 3, divided by the number of rice 1, we have 3 over 1. Okay, then I can do that again here for this. If I have 2 cups of rice, it's going to feed 6 people, so that's 6 divided by 2. Okay, then I'll do the same thing here. 9 divided by 3, 9 people for 3 cups of rice. Now, what is 3 divided by 1? What is that ratio? How could we simplify it? 3 over 1 is the same thing as 3, because 3 divided by 1 is 3. 6 divided by 2 is 3. 9 divided by 3 is 3. So when we take the ratios that relate the quantities, right? X to Y, the number of rice and the number of people, we get 3 for all of those. Okay, so that means we have a proportional relationship. And that number 3 is very important. We can call that the unit rate, as we see here, or the constant of proportionality. So the constant of proportionality can be found by dividing y divided by x. And another way of thinking about it is it's this constant number we multiply by to get from one variable to the other, particularly from the x to the y. So 1 times 3 is equal to 3. 2 times 3 is 6. 3 times 3 is 9. There's that constant number we can multiply by that takes us directly from x to y. So this is what they'll look like in table form. And then today we're also going to think about what they look like in an equation form. So proportional relationships can always be represented by the form y equals k times x, where k is the constant of proportionality. Or sometimes, and this will lead into what we do more next week, we can write this y equals m times x. I don't want you to worry about the k versus the m, because ultimately it doesn't really matter. We're taking our x value, multiplying by some constant number, k or m, and then we get y, the y value. Whenever you see any equation in this form, we know we are dealing with a proportional relationship. So for the rest of this video, we're just going to look at one kind of example of comparing two different proportional relationships, one that's presented in a table form, one that's presented in an equation form, and then we have these 5 questions to answer about them. Sebastian has 2 plants that he takes care of. The table compares the height of plant 1 based on the number of weeks after he planted it, right? So he measures it every week to see how tall it is. And then the equation y equals 4.5x represents the height of plant 2. Y is going to be the height based on the number of weeks after he planted it, x. Okay, so we're really thinking about the same like 2 variables, the same 2 quantities, and then the same like x or y, right? Our weeks is going to be our independent variable. It's what he has control over. That's going to be our x. When is he actually measuring it? 1 week, 5 weeks, 10 weeks? How long after he planted it. And then y is the dependent variable. That's how tall the plant is going to be at that time. All right, so our first question is, what is the constant of proportionality for plant 1 and for plant 2? Finding the constant of proportionality for plant 2 is really easy, so I'm actually going to start there. So we know that for any proportional relationship, we have y equals our constant of proportionality, k, times x, okay? So the constant of proportionality is just whatever number k is, whatever number fills in this space of k, which here is 4.5, right? It means that when I take my x, which in this case is the number of weeks, multiply by that 4.5 by the constant of proportionality, I'm going to get y, which in this case will be the height. Okay, so for number 1, the constant of proportionality, k, equals 4.5. Right? We also need to do this for plant 1. This is a little bit more challenging in table form. So in order to find the constant of proportionality, in the case of these proportional relationships, we can just take the y value and divide by the x, right? Because that's this constant ratio, y divided by x. However, what's going to help us later, which we'll see in like 2 weeks, is instead of just thinking about the actual y value, we're going to think about the change in the y value versus the change in the x. So to see what I'm talking about, height is going to be my y. So let's think about my y here. What's the change when I go from 8 to 12? In this case, we're thinking about adding and subtracting. So 8 plus what gives me 12? 8 plus 4 gives me 12. Okay, so we're going up by 4, we're adding 4. And then for my x, I'm going to do the same thing. From 2 to 3, what does that change? 2 plus what gives me 3? 1. Okay, so to find k then, I can find my constant of proportionality by dividing the y divided by the x, or the change in y divided by the change in x. Okay, so in this case, the change in y was 4, the change in x was 1, so k is equal to 4, because 4 divided by 1 is 4. Okay, I can also see that from the table, right? The constant of proportionality, that's what I'm multiplying by, the constant value I multiply by to get from x to y. Okay, so 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, 5 times 4 is 20. So there's a constant number that I multiply by that takes me from the x to the y. Okay, so that means I have a proportional relationship, and that number is my constant of proportionality. Now let's take a look at number 2. What do these constant of proportionalities mean in this scenario? Okay, so I'm talking about plants, and then all of a sudden I said k equals 4. What the heck am I talking about? Well, let's really focus in on the units here, because that's what's going to be important. So I'm going to go back to this stage when I was trying to find the k from plant 1. When I was talking about my y value, the y value has a unit of inches, right? When I'm talking about 4, I really mean the height, 4 inches. And then when I was talking about my x's, I'm talking about weeks, right? That's the unit for my x coordinates. So what I see here then, it is not just the number 4, it's 4 inches per, because whenever we think of division, that could be per, 4 inches per week, or for 1 week per week. Okay, so 4 inches per week, I'm talking about the height of the plant relative to the number of weeks after he planted it. Okay, so in this case, this constant of proportionality means the plant grows 4 inches per week. So it gets 4 inches taller every week. Okay, and then that's going to be the same for plant 2 because we're talking about the same units. So for plant 2, it's getting 4.5 inches bigger per week. Now let's look at our third question. Write an equation that represents plant 1's height based on weeks. Okay, so I already have my equation here for plant 2, y equals 4.5x. But plant 1, they give it to me in table form. So I need to work the other way and figure out what the equation is. Okay, so generally for any proportional relationship, and we already figured out this is proportional, we have the form y equals k times x. Okay, and we just need to substitute in a value for k, our constant of proportionality. Well, what's our constant of proportionality for plant 1? 4. Okay, so the equation is just y equals 4 times x. And that equation relates and explains this relationship we see in the table. We see in the table that you take x, we multiply by 4, and that gives us the y coordinate every single time. So that's what this is saying. Take x, multiply by 4, and we get y every single time. Question number 4, how tall is plant 2 4 weeks after it's been planted? Okay, so I know how tall plant 1 is 4 weeks after it's been planted. They tell us that really nicely here in this table. They say after 4 weeks, it is 16 inches tall. But for plant 2, they don't give me that information. However, they do give me a really important equation. So I can use that equation to find the height, y, of plant 2 based on any number of weeks I want to. That's the great thing about equation. We can substitute information into it and figure out lots of new information. Okay, so to do this, I'm going to rewrite my equation, y equals 4.5x. And then what I'm going to do is I'm going to substitute in, and I know this is a word we talked about a lot last year, substitute in 4 for x, because they're talking about 4 weeks after it's been planted. X is weeks. X is weeks. So I'm talking about 4 weeks after it's been planted. I'm going to substitute in or plug in, put in, replace x with 4. Right? And then that's going to give me the answer. I just need to evaluate this, figure out what this is. So y is equal to 4.5 times 4. 4.5 times 4 is 18. I know that because 4 times 4 is 16, and then 4 times a half, or 0.5, is 2. And I can add them together. So I get 18. All right, and 18 what? 18 inches, because now I'm talking about y. And when I talk about y, I'm talking about the height of the plant in inches. Okay, so in this case, then, for plant 2, it is 18 inches tall after it's been growing for 4 weeks. All right. Great, we are almost there. So then finally, which plant is growing faster? Explain. Well, let's just compare the 4-week situation. After 4 weeks, how tall is plant 1? Plant 1 is 16 inches, which we see right here. And then after 4 weeks, how tall is plant 2? 18 inches. Okay, so plant 2 is taller after 4 weeks than plant 1 is. So which one's growing faster? Plant 2. Okay, but I don't have to just look at that to see it. I actually know that right away once I find the constant of proportionality. Plant 2's constant of proportionality is bigger, it's larger than plant 1's. So plant 1 is going to grow 4 inches per week, which is solid, but plant 2 is going to grow 4.5 inches per week. So it's growing faster every single week. All right, that's all it is. Great job, everyone.